Hello everyone. Today we are going to discuss on what's new in Wireshark 4.0, which recently got released in October 2022. Level of this discussion will be going to be intermediate, and the prerequisite for this is like you should have some understanding on Wireshark. If you don't, I already have made one video on Wireshark detailed features and what is it used for. So I'll be putting the link in the description. You can check it out before continuing with this. Um, Flow of this discussion will be a quick overview of Wireshark. I'll be providing very brief view of Wireshark, what is it used for, and some of the highlights. And then I will be continuing the discussion with the new changes which came in Wireshark 4.0. And also, I'll be discussing on some of the filters, which are very nice filters came in Wireshark 4.0 to make our searching very useful and very efficient. So let's get started. Before that, I'll just going to explain the if config. If config is like we can list out the interfaces on your system. So I am currently using MacBook M2 chip. So as you can see, there are a lot of virtual interfaces. So these basically these will be the interfaces I will be shown in the Wireshark as well. So let me open the Wireshark here. If you have noticed this, here there is one graph going on. So earlier in the previous Wireshark versions, what they had is like just a straight line. So we would never like know what's going on with these interfaces. So I have all the list of these interfaces here. So what they have like main change came in 4.0 is like whatever the active interfaces currently are, there's a traffic going on those interfaces are on top. So they are like sorted on the basis of traffic. So based on the highest traffic, like it's on the top and then coming down. So like that, they have listed down. So from here, you would know that on which interface you really want to, they say like capture the traffic, right? So from here, you would know that okay, the traffic is going on EN0 interface, which is nothing but my Wi-Fi interface. I'm connected to Wi-Fi router, and loopback is a localhost interface, 127.0.0.1. So whatever the traffic internal communication is happening, internal sockets, they were communicating on that local host. So that communication is being the traffic graph is being shown here. So from here, it's very noticeable that which interface are currently having the traffic flow, and then you actually want to capture the traffic on those interfaces. Okay, so if I just go ahead and just click on this EN0, it will start showing me the whatever the type of traffic is going on this interface. As you can see, it has already started. Some of the UDP packets are going. Uh, okay, so this is the like traffic flow is going on this. Let me go ahead and show any packet capture. So this is the ultimate pcap. So the packet capture, all the most of the packet protocols are in this file. Let me open this. So this is a huge file with the packet capture, which will have list of packets. So first of all, let's go ahead with the one very important change came in this. It's like when you have some packet, right? Let me filter out a GRE packet. So GR is a generic router encapsulation. Is a protocol which is used for tunneling purpose. Like you can encapsulate your IP header till IP header. You can encapsulate your payload into a GRE packet, and then it will have a source IP and destination IP of its own. GRE there is a IP Internet Protocol IPv4 packet, and then on top of that there is a GRE packet, and then there is another source and destination IP address, right? This is how you can encapsulate your payload till IPv4 inside the GR encapsulation. So when this packet will be decapsulated, right? So at the receiver end, it will decapsulate this Ethernet packet, Ethernet header first, and then it will go ahead this Internet Protocol packet, and then it will know that okay, it's a GRE packet. The next protocol type is a IP, which is a IPv4. So this next protocol type and all these fields I already explained in detail in my previous Wireshark video. I'll be putting the link in the description. You can go ahead with the detail. What I'm trying to focus more on here is like you can uh, now it's really difficult to like if you want to filter out something on IP source, then you would be earlier you would be just filtering out the IP source, and that those IP source could be like outer header, right? So there is a Internet Protocol IPv4 header outside. So now inside the GRE also there is another IP header. So how would you know that which of the IP header to filter out? So there is something came in Wireshark 4.0 is like you can filter out on IP dot source, and you can filter out hash two. Hash two is like the sequence of the header. So IP header is like there are two IP headers inside this. So it would be saying that this is the hash one, and then the second one after GRE header is a actual IP header, right? So it's a hash two, and then there is another GRE on top of it. So like that, you can basically filter out which layer you want to get the information out. So I have already found one like IP, which was very common. So I'm just going to put that as an example here. So now you know that in this, let's take the example of ping here. So now you know that here, if you see that there is one IPv4 IPv4 header outside, and then there is a GRE, and after GRE there is another IPv4 which has a source of 56, and you can notice that the color is highlighted now. So it is not filtering out the first layer; it's only filtering out the second layer of IP dot source. So that is how you can tell it to which layer you want to see the IP dot source. So what it means by hash two is like it will skip the first filter, even if it is there, it will not match it with this one. It will only match with the second layering of IPv4 header. So the benefit of this is like if you have this kind of packets, right, GRE or IPsec tunneling kind of packets, then you would be. It's very easy to filter out those kind of packets with this nested filters. Yes, this is very useful thing came in Wireshark 4.0. So next is like there is a arithmetic operations you can now apply on this data. So let's say you have TCP packet. Okay. So now in TCP, any of the packet, you will have this length, right? Um, so basically, you can basically check the length and length of the packet, and you can apply filter on it. So now, let's say you want to know if there is any TCP header with a length of any, let's say 22. Okay. So now, what it is actually doing, it's checking that if the TCP header length is in multiples of 20. Now, if the TCP length is in multiples of 512, then you would be knowing that this is the multiples. Basically, you can apply arithmetic operations on this length, and you'll be knowing that if there are packets in the multiple of this, so it's really easy to filter out these kind of packets, which are basically ingress on those in this interface, and you can apply these arithmetic operations. So next one is like say you want to know like if any of the TCP packet. The complete TCP payload, you want to fetch the first 2 bytes, or you want to apply any of the like equal operators on this. So let's say you want to know if any of the TCP packet which has first 2 bytes as a zero. Okay, so now what you can do TCP payload, and you can put an array, and then you can put 0:0:2 means like you can starting from zero offset, and the two is the how many bytes you want to match, and then is equal to, you can put the values in hex 00. Yeah, so as you can see now, I have applied filter. It will show that the first 2 bytes of TCP payload is 00. So if I just click on TCP payload, the first 2 bytes, you will notice that are 00. This is 1 byte, and then this is second byte. This is how you can filter out. And if you want to know you want to know from end, you can just put negation, and this is the offset. Last 2 bytes from end is 00. You can just go in the payload, and you will know that from the last two offset, you can know that these 2 bytes are 00. So this is how you will know that last 2 bytes. So this is how you can filter out the packets if you actually have some information, and you can just want to see those payload based on the payload or any of the sub values of TCP or any protocol. You can apply this filters like this. There are many more such information available. I just wanted to show some very cool highlights on this 4.0 feature, but you can always go and refer the release note of this Wireshark 4.0 5.0 release. I'll be putting that link in the description as well. Um, and I will also be continuing with some of these protocols which I mentioned, referred here, like GRE, like that. I'll be continuing some of the information. I'll be continuing some of the discussion in further videos. That's all I wanted to discuss on this Wireshark 4.0 feature. If you have any doubts, you can go ahead and put the comment on this video. I will be reading those, and I will be responding as soon as possible on those comments. Thank you all for watching.